So electric potential. So what is this electric potential is the work done in displacing a particle or work done in moving a particle from infinity to the distance. So potential can be written as an work done in moving a positive charge from here. And the SI units for the electric potential is going to be the volt or it is joule per coulomb. Okay, so from this one you can write the dimensional formula for the potential as an that is dimensional formula will be L to the L square T to the power of minus 3 and that is an ampere inverse. This is the one. Okay, ma'am. Now this is the general formula of the potential. If I substitute the potential or how to derive this potential. Or the work done in moving a unit positive charge can be written as an 1 by 4 pi epsilon naught charges q naught by r. If I am bringing a charge called as an q or to the q naught. So this is the already existing charge q naught. We are bringing a charge called as an q from infinity to a specific distance called as an r. So work done will be this particular things up to that particular value r. Now if I substitute in this one, potential V is equal to 1 by 4 pi epsilon naught. This is q naught by r divided by the q. You can remove these two things, which is 1 by 4 pi epsilon naught. This is q naught by r. There is a potential because of a point charge. So similarly, you can find the potential due to the different things. For example, you have got a positive and a negative charge here. Then at the midpoint, the potential will be zero if the charge values are same. That is an potential of two opposite charges or two unlike charges. So at midpoint is how much? Zero. If I take the two, that means since it's an scalar quantity, the net potential will be equal to the sum of the potentials V1 plus V2. Since in this case both of them are the positive charges, it will be 1 by 4 pi epsilon naught q by at the midpoint if the distance is some r or the total distance 2r and kunte, then this will be the 1 by 4 pi epsilon naught q by r. So this is how for the first case here, the net potential is going to be the 1 by 4 pi epsilon naught. First charge is a positive charge, I can write the plus q. And since the second charge is going to be the negative charge, 4 pi epsilon naught minus already I have placed over here into r. So sum will become 0. So that is what. So here the net potential will be, net potential is the algebraic sum of all the potentials. Algebraic sum of all the potentials at that particular point. So remember this point, if you have the multiple charges are there, number of charges are there, so you can apply that particular thing. Okay. Now potential difference. Potential difference. Potential difference is also nothing but an actually you can write this one. So the work done in moving a charge, the work done in moving a charge, is capacitance start చేయలేదన్నా start చేయంగానే చెప్తాను. In moving a charge is been given by work done W is equal to minus Q into integral of E bar dot actually it's a dr bar. So from this one, work done by charge can be written as an delta V, that is the potential difference, minus of integral E bar dot dr bar. This is the potential between the things. So this is E bar dot dr bar, right now, Naidi? So this is your potential difference, nothing but an. It is the potential in within the region between the 2 points. Suppose you are bringing a charge called as an Q naught from the infinity. The potential at the two different points, that is A and B, within the region or within the electric field, is called as your this particular potential difference. So potential difference can be written in this particular format between the points some A and B within an electric field. So for a uniformly charged wire, for a uniformly charged wire, potential difference can be written as, and that is delta V is equal to, you can able to find out by integral of electric field for a charged wire at a infinite distance is lambda by 2 pi epsilon naught r into dr. We are changing from the radius distance r1 to r2, and this will be equal to the lambda by, this is 2 pi epsilon naught into negative value is there. This is log of r, where the values are changing from r1 to r2. If I take the minus sign inside, lambda by 2 pi epsilon naught of, it is ln of, you can write it as an r1 by r2. It is the potential difference for a uniformly charged wire. అదే ఒక రింగ్ ఉందనుకోండి, what is the potential because of the ring? Potential due to a ring. So how can you calculate this potential due to a ring? In the sense, it's a very simple. Consider a normal ring over here. So along the axis at a particular point P at a distance x, and the radius is going to be the r. So this particular distance is going to be the root over r square plus x square. Then V is equal to 1 by 4 pi epsilon naught into charge on the ring, that is total charge Q by root over, that will be the r square plus x square. In this case, if x is equal to 0, that means at center, potential is equal to 1 by 4 pi epsilon naught Q by r. Okay, na? So this is the thing, please. This is the basic thing. So general formula, similarly, you can also find out the potential of a ring and all these disk and all these things. That is the potential of the disk is potential of a disk is this will be derived, or V is equal to, it is sigma by 2 epsilon naught of root over r square plus x square minus x. It is the potential due to the disk, please. Is the potential due to the ring, here we have written. Okay, now so earlier case, this is your ring, nana, potential due to the ring. So the integration of the potential due to the ring from 0 to r will give you the potential due to a disk, right? So I'm going to the next one. Next one, potential due to a sphere. Potential due to a shell. So for a shell and the sphere, you can have the three surfaces. One is outside the shell, another one is on the shell, another one is going to be the. So if the point P is here and the radius of the shell is r, where small r is going to be greater than the capital R. So this is outside the shell. Potential can be written as, and this is 1 by 4 pi epsilon naught charge, total charge Q by small r. Next, on the sphere, if you come down, on the sphere, potential V is equal to 1 by 4 pi epsilon naught, which is going to be the Q by capital R. So next, inside the sphere, it will be also the same value, that is V is equal to, because it remains constant, 4 pi epsilon naught into Q by R. Since inside a shell, or inside, if I take it as a shell, inside the shell, the field will be 0. Since the field is equal to 0, V is equal to integral of E bar dot dr, that will be equal to 0. That is potential difference with 0 means potential on the surface and potential inside will be same. So similarly, if I take or for the graph for this one, how do you get the shape of the graph for the shell is? So inside at every place it is constant V on the y-axis and a distance r on the x-axis. So inside at every point it is constant. This is the region where small r is less than capital R. Small r is equal to capital R, and after that it is inversely proportional to the r. So it's a rectangular hyperbola for r greater than the capital R. Now for a sphere the values will be same for as an outside will be same as a shell, which is 1 by 4 pi epsilon naught q by smaller. On also it will be the same. On the sphere, the value will be same, that is 1 by 4 pi epsilon naught into q by capital R. The only thing is, inside the sphere it's going to be changed. Inside the sphere, it will be, because the field inside a sphere is different, it is 1 by 4 pi epsilon naught q by r cube into small r. So when you integrate that particular thing and solve it, you'll be getting the inside at any point. It's a very, very important formula, Andy. So it will be the q by 4 pi epsilon naught into 2r cube of 3 capital R square minus small r square, where small r is less than capital R, the distance from center. R is distance from center. Okay, now this is the condition. Fine. So these are the different formulas of the potential here. Okay, so what do you mean by the potential gradient? Potential gradient, or the relation between field and potential is, so what will be the relation between both of them is, it's another important relationship, that is E bar is equal to minus dou V by dou R, or this can also be written in an elaborate form of E bar is equal to minus of dou V by dou X I cap plus dou V by dou Y J cap plus dou V by dou Z K cap. Or this can also be expressed as E bar is equal to Ex I cap plus Ey J cap plus Ez K cap. So this you can, the relation between the electric field and this one, any physical quantity by the distance is called as that gradient. So dou V by dou R is potential gradient. Okay, so next we'll go for the equipotential surfaces. Sorry. So equipotential surfaces, what are your equipotential surfaces? So the surfaces where, or the surfaces on which at every point You have a same potential. Suppose there is a positive charge here, so it is surrounded by another one. So like this, where the radius of these shells are going to be the same. So potential on these points will be equal. Potential, so these surfaces, it's not that potential, or here if it is V1, here the potential will be V2. So potential is not going to be the same at every point. At every point, that means on the circle, potential at every point will be same. But as the radius increases, potentials need not to be the same. So these surfaces are called as your equipotential surfaces, please, on these lines. So what will happen on the equipotential surfaces? Potential difference will be zero. That is delta V is equal to zero. If I take this as a point A and this is a point B, in the sense VA minus VB is equal to 0. That implies work done on equipotential surface is 0. So work done on the equipotential surface will be 0. That is W is equal to 0. So electric field E bar is always perpendicular to equipotential surface. Equipotential surfaces. Right, sir? So on the distance should be perpendicular to the equipotential surface. Remember that particular point. Generally, these type of the questions will be given to you on the equipotential surfaces. Suppose this is the potential and this is the distance R. These are your equipotential lines and kunte. And if they make an angle 30 degrees, this is your perpendicular distance you need to find out for the equipotential surface V1, V2. So E bar is equal to minus of V2 minus V1 by this is the perpendicular distance R you need to substitute.